Okay, welcome back. We are now going to do our last type of factoring. So just to review again, the factoring order that we have learned so far is first and foremost, you always common factor. You always look to see if there's a common factor. Then we can do simple trinomial next if it's a trinomial. So simple trinomial, and you know it's a simple trinomial because the number in front of the x squared is a 1. If it's not, and it's still a trinomial, then we're going to do complex trinomial, better known as decomposition, where the a value isn't 1. Okay, so it's one or the other. If it's a trinomial and the a value is 1, you're going to multiply to the back and add to the middle. That's this one. If it's a trinomial, where the a value is not 1, so you're stuck with a 2 in the front or a 3 in the front of the x squared, you have to do that 3-step process called decomposition, where you go first times last. The last type of factoring then is going to be the special cases, which basically is a difference of squares. Difference of squares. And it looks very different than what the previous ones looked like. So it's going to be easy to tell when it's that one. So I'm going to show you what I mean. So just to get us started again, let's expand and simplify these brackets. So we have to expand and simplify, and because it's two things meeting up with two things, this is a FOIL situation. So it's not going to say use FOIL, first, outside, inside, last. So you have to realize that, oh, two things meeting up with two things, I should get 4 terms in my expansion. And then the two inside guys, negative 3x, and then the two last guys, right? Negative 9. Now again, we always collect like terms, 3x, so positive 3x minus 3x means no x's because plus 3 minus 3 is 0. So you don't write 0x. So we have an x squared in the front, and we have a minus 9 in the back. That's it. The x term in the middle went away. So no x term. All right, let's do the next one. Let's FOIL out that guy. So what do we have here? Again, two things meeting up with two things. This is FOIL. So first times first is 4x squared. Outside guys is 2x. Two inside guys, negative 2x. See what's happening to the inside guys? And then last times last is minus 1. That gives me 4x squared. No x's in the middle again. 2x minus 2x goes to 0. And then a minus 1 in the back. No x term again. All right, let's try this last one. 3x plus 2, 3x minus 2. So what happened? This is another FOIL situation. So again, first times first is 9x squared, negative 6x's, positive 6x's, negative 4, which gives me 9x squared minus 6 plus 6. They go away again. And then a minus 4 at the back, so no x term. There's no middle term. We have the a and we have the c, but we're missing the b. So what do you notice about each of the answers from the above? The two middle terms cancel out. So the two middle x terms cancel out. So simplify out. So that means it's just ax squared, right? Something in front of the x squared, and then minus c. Do you notice that it's a minus, and a minus too? So this is what it looks like in expanded form. So what do we notice? That there's no middle term because it cancels out, and that we have something squared in the front, and we have a minus number in the back. Something else I hope you notice are what kind of numbers are 1, 9, 4, 1, 9, 4. So those are very special numbers. Those are what we call perfect squares. So the A and C numbers, coefficients, are perfect. Oh my goodness. Let's try to write this properly. Are perfect squares. Okay, so what does that mean? Perfect squares. They are square rootable. You know the square roots to them. So square rootable is not really a word. So examples would be 1 is a perfect square because you know the answer to the square root of 1. You don't know the answer to square root of 2, square root of 3, square root of 4. You don't know 5, you don't know 6, you don't know 7, you don't know 8, but you know 9. Next one would be 16. The next one would be 25. So how am I getting these? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, right? And it keeps going, right? 169, so forth. So these are the numbers you look for. These are your perfect squares. So notice 9, 4, 1, 9, 4. Those are on the list. They worked out to be the numbers we get. So the question then becomes, how do we go backwards? So how do you start with this and know that it's supposed to look like this? How do you start with this and know that these were the two brackets that it came from? Okay, so if I wanted to factor, so to go backwards to factor, we need to square root the coefficients, right? So the square root of 1 is 1. Place it in the front of each bracket. The square root of 9 is 3. Place it in the back of each bracket. One bracket gets a plus, one bracket gets a minus, and that's what causes the two middle guys to cancel out. Let's try it over here. Square root the coefficient, 4. Square root of 4 is 2. Stick 1 in the front, stick 1 in the back. So the front of the second bracket. X squared needs to be split in half. So we need to square root the coefficients. We need to divide exponents by 2. Because half of them go here and half of them go here. So x squared, you get a single x, you get a single x. Square root of 1, stick the answer in the back of each bracket because he's the second one listed. One gets a plus, one gets a minus. So we square root the coefficients, we divide exponents by 2, so that means we must have even exponents. So therefore exponents must be even. That is key. So that means x squared, x4, x6, x2y4. Like it needs to be those kinds of combinations because we have to split them into even groups. So we need to square root our coefficients, split our letters in half. So half go into each pile. So we divide the exponents by 2. And then one bracket gets a plus, one bracket gets a minus. So what am I talking about here? In general, for people that need to kind of see it before we apply it, we have ax squared minus c. I want to now put this into brackets. Okay, I'm trying to factor this. What I'm going to do is I'm going to put the square root of a, whatever the square root of a is, stick it in the front because it was the first thing that was listed, right? Then I'm going to cut this exponent in half. He gets one portion, he gets the other portion. It was attached to the a, so it's attached to whatever the square root of a is going to be. Square root the back. So whatever the square root of that constant is, stick that answer in the back. One gets a plus, one gets a minus. Okay, so that's the pattern that we apply when we do what's called the difference of squares. So if something looks like this, two terms that are square rootable, these numbers, separated by a minus sign, has to be a minus, can't be a plus, with even exponents, then you know it's this form. You don't have to do decomposition, you don't have to do simple trinomial, you just go straight into your brackets and place the numbers where they go. So let's actually practice here. So we have x squared minus 5. So you go through, still, all the same pattern here. Do you see a common factor? X squared minus 25? No, there's no common factor. Skip it. Is it a simple trinomial? Well, it's not even a trinomial, right? A trinomial has 3 parts. This isn't 3 parts. This is 2 parts. So it's not decomposition. It's not simple trinomial. So is it a case where you have a square rootable number and a square rootable number? 1 in the front, yes, is on the list. 25 in the back, yes, it's on the list. Separated by a minus sign, yes. Even exponent, yes. So this is a difference of squares. So this is where we quickly go into just 2 brackets. 1 is just 1. You can put the ones or leave them out, your choice. X squared gets split into half. Half goes here, half goes here. So half of 2 is 1. You get a single x and a single x. And because, again, the x is holding the spot, the ones actually don't need to be there, right? They're understood to be there. Square root of 25. We're not dividing by 2. We're square rooting this number. This number goes into the back. One bracket will get a plus. The other one will get a minus. And again, to check, what you need to do is you just need to expand that out. And you need to check that it actually matches up to what you started with. And you'll notice that the middle terms separate and cancel out. All right, let's try this next one. We go through the same method again. Okay, so we have a 4 and we have an 81. The only thing that goes into 81 would be 9. 4 is 2 and 4. We common factor, so I didn't see anything. But 4 and 81 are good numbers because they're on our list, right? 4 and 81 are square rootable. We also have an even exponent and we have a minus sign. So this is setting us up again for a difference of squares. So again, equal sign, next line down, 2 sets of brackets. Square root the first number that you see, which is 4. So that becomes a 2 and a 2. The letter attached to it, you split the x squared into one portion and one portion. We square root 89. 81 becomes 9 and 9. One gets a plus and one gets a minus. And again, I checked 2 and 9, 2 and 9, nothing can come out of those brackets, so they're already in lowest terms. So it doesn't matter that the number in front isn't a 1. In this case, it's a 25. And here it's a 49. 25 and 49 are again both on the list. Here we have x4 and y2. So it doesn't matter that there's a y squared in the back here. The fact that they're even exponents is all we care about. Because again, we can split them into 2 equal portions. So again, no common factor. It's not a trinomial, so it's not simple trinomial. It's not decomposition. It has to be this difference of squares. So bracket, 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 bracket. The square root of 25 goes to the front. Well, that's 5 and 5, right? Because 5 times 5 gives me back 25. X, he has x's attached to him, but how many? I started with 4, so that means you get 2 and you get 2, right? We cut them in half. In the back, 49. 49 square rooted is 7. Attached to the 49 was y squared. So again, equal portion, a single y and a single y. Because when we times 7y by 7y, we get back 49y squared. Again, one gets a plus and one gets a minus. I always tend to put the plus one in the front because it's the minus one, the subtract one, that you have to check that can't go any further. Because this second bracket that has the minus sign could be another difference of squares. So it's important that you always check to make sure that you've gone as low as you can go. So I'm going to show you an example of that momentarily. And it doesn't matter that they're fractions, right? Look, the w has an even exponent, the x has an even exponent, the y has an even exponent. 1 over 9. 9 is a good number, 1 is a good number, 4 is a good number, 25 is a good number, and separated by a minus sign. So it checks off all the boxes. So again, there's no common factor, not an easy trinomial or decomposition. So what we're going to do is 1 square rooted is 1. 9 square rooted is 3. So 1/3 times 1/3 gives me back 1/9. W to the power of 2. W to the power of 2. X to the power of 1. X to the power of 1. So we cut the 4 in half and we cut the 2 in half. 4 square rooted is 2. 25 square rooted is 5. And 2/5. A single y and a single y. And in between these two terms, one has to be a plus and one has to be a minus. And there we go. And again, can't do anything more with those brackets. So you look at this next one, 12x squared minus 3y6. And you're like, but wait a minute, these numbers don't work because I don't know the square root of 12 and I don't know the square root of 3. And you're right, they don't work. But remember that you have to common factor first. And if you pull out the 3, which you should always pull out at the beginning, when I drag out the 3 in the front, what am I left with? 4x squared minus 1y6. Now it's a difference of squares, right? So you keep going now with the bracket. It's being split into two more brackets because 4 is square rootable, x has an even exponent, y has an even exponent. So you're going to stick a 2x in the front of each bracket, and you're going to stick y3, right? Y cubed into the back of each bracket. One gets a plus, one gets a minus. So again, always remember to common factor first, because you may not see that it's a difference of squares until you pull out that extra number that's in there. Last one here, the numbers look big, but 256 is square rootable. So you can check your calculator. The square root of 256 is 16. So square rootable, square rootable. Now, is there another number that goes in there? Well, if we don't see it at the beginning, let's see if we see it at the end. So not a trinomial. The x has an even exponent on him, separated by a minus sign. This all looks good to me. So square root of 256 is 16. Stick them in the front. x8 cut in half is x4, x4, right? 8 cut into 2 equal portions is 4 and 4. At the back, 9 and 9, because that's the square root of 81. One gets a plus, one gets a minus. So you might be sitting there thinking, oh, I'm done. But no, you're not done. And it's true, 16 and 9, there's no common factor, right? It's not that we missed a common factor. But what you have to realize right here, there's still more difference of squares. So this one, the one here that I put the little star next to, because of the minus sign, it's two terms separated by a minus sign. 16 is square rootable, 9 is square rootable, x has an even exponent. This gets broken down into two more difference of squares. So still another difference of squares. So you keep going. That first bracket with the plus sign, you can't do it because it's a plus, right? That's not a difference of squares. So 16x4 plus 9, copy them down. This gets broken down into two more brackets. So what do we get? Square root of 16 is 4. Stick him in the front. x4 cut in half, x squared, 9 square rooted is 3, and 3 plus minus. Always check the one with the minus sign. Make sure that you can't go further. You could never go further with these two because they have plus signs. That's why I always do plus then minus, because it's always the back bracket that I need to make sure I check. But check, look, 4 is a good number. X has an even exponent on him. There's a minus sign. But unfortunately, 3 is the one that's not square rootable. So this is as low as you can go with that back bracket because the 3 ends up cutting it off at that level. Notice again that we just copy down anything from the previous line, right? Anything from the previous line just gets copied down. Don't lose it up in a previous line. Everything must be copied down because what you're saying is this line is the same, equal to the same thing as this line, which is equal to the same thing as this line. You can't leave portions of the answers somewhere up above. Okay, but this is still pointing out a good component, which is always check to make sure that you can't go further. And you always check the one with the minus sign, okay, that you can't, to make sure you can't go further. I always trick students because they stop too early with those types of questions. Okay, so that was a difference of squares. Very simple, straightforward process. Bracket, bracket. It's not as much work as decomposition. And it's a dead giveaway of when you need to use it because you're looking for those clues, right? Those special numbers and even exponents. Okay, so now what happens though when it's a trinomial, so not a difference of squares, but the numbers are nice numbers, meaning 4 and 9 are nice, 25 and 16 are nice, right? That's what I mean by nice numbers. So again, like before, we're going to see if we see the pattern. So if I asked you to expand and simplify each of the following, I'm going to do the quick way. Just to review, what is the quick way? Because notice it's the same bracket times itself. So remember what that means. X plus 3 times another x plus 3. So you could do FOIL. So go ahead if that's what you want to do. So do your FOIL technique. I'm going to do the quick way where I'm just going to square the first term, times these two together. X times 3 is 3x. I'm going to double it to give me 6x's because I'm going to get 3x and another 3x, which gives me 6x, and then square the last times itself. So that's my final answer. Again here, FOIL out. If you're that style of person where you need to do complete FOIL, I'm going to do the quick way. 2x times 2x is 4x squared. 2x times negative 1 is negative 2. Negative 2 doubled is negative 4x's, and 1 times 1 is 1. The back will always be positive. The front will always be positive. Because when you times anything by itself, a negative times a negative is always a positive. And the last one here. So again, if you're doing FOIL, you want to get ahead of me. 3x minus 2, 3x minus 2. Go ahead, FOIL that out, collect your like terms. Quick way, because again, it's same times itself. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x's, but double is negative 12x's. And then negative 2 times negative 2 is positive 4. So what do you notice about each of the answers? So each of our answers, notice that 1, 9, 4, 1, 9, 4. The A and C coefficients, values, so the numbers, are perfect squares. So that list of 1, 4, 9, 16, 25, they match. And then that the middle term comes from this number that's in the bracket, and the sign matches, so minus, 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 minus. So the sign of the B, so the sign of the B term matches the sign in the binomial. So basically, you'll have what's called a perfect square trinomial, that will result in a bracket that repeats, as a factor. So the dead giveaway, and how we can do it quickly when it says factor each of the following, this would be a decomposition question, right? Because you're stuck with the 4 in the front, you can't common factor. So it's decomposition, which is 3 lines, or you notice that it's a perfect trinomial, perfect square trinomial. Now, it doesn't matter if you notice it or not, trinomial, because either method works. But for people that notice these things, let's see if we can figure out what the numbers must be. So 4, right? 4 must be broken down into 2 and 2, x, x. Obviously, I need a 9 in the back. Well, where did 9 come from? It comes from a 3 in the bracket. So I'm pointing up here. So a 9 in the back comes from a 3 in the bracket. So there must have been a 3 here and a 3 here. And the sign, whatever the B term is, seems to be what repeats, which would then just be 2x plus 3 written down with a square on it. So try, right? See, does this work out? So we're going to check our work by expanding. 2x times 2x is 4x squared. 2x times 3 is 6x. 6x doubled is 12x's. And 3 times 3 is 9. Does it match? Yes. Okay, so again, the dead giveaway, perfect square, perfect square. Okay, those are the dead giveaways. And it's a trinomial. So again, we could do decomposition, first times last, and think of all the numbers that multiply out to that. but 25 and 16 are great numbers. So I know that I can probably get 5x, 5x, and a 16 might be a 4 times a 4. This is a minus sign, so minus minus, which would be 5x minus 4, just with a square on it. Again, check to see. So what's 5x times 5x? 25x squared. 5x times negative 4. That's negative 20. Negative another 20. There's negative 40x's, and a negative times a negative 4 is a positive 16. Check. Yes. Okay, so again, this method only works, guys, in cases where those numbers are perfect squares, right? Because we're getting the same thing times itself. That's what gives us 25. That's what gives us 16, right? Same times same. Okay, notice something's wrong in this one, because right away you see 72 is not good, 24 is not good, 2 is not good. Those aren't perfect squares. But you have to remember common factor first. If you see a common factor, you should always pull that out first. So something that goes into 2, 24, and 72, I'm going to pull out the negative as well, because I don't like the beginning starting with a negative. So negative 2 goes into everything. Nothing else comes out. So positive x squared, negative 12x's, positive 36. Now this is a perfect trinomial. So I say trinomial and I always forget the no part in trinomial. Okay, so let's try this again. Trinomial. My hand needs to slow down. So why is it a perfect trinomial? Because 1 is a good number, square root of 1 is 1, and the square root of 36 is 6. We don't care about the middle. The middle is going to come from the FOIL technique, right, of the outsides and the insides being added together. All I care about is the first and the last. So let's see if we can come up with these numbers without actually having to do simple trinomial, right? Two numbers multiply to 36 and add to 12. Well, x, two numbers to multiply to 36 and add to 12. This is a simple trinomial question as well. 6 and 6, the signs are the same. They're both minus. We would have gotten this if we had just applied the perfect trinomial question and not a simple trinomial question, but it's the same thing, right? Two numbers are multiplied to 36, 6 and 6, 1, x, 1x, both of them are going to be minus. And you get the same thing. So you end up at the same place in the end anyway, whether you see it as a simple trinomial or whether you see it as a perfect trinomial. And last case over here. Again, I see 12 and 75. I'm not happy with those. Can we do better? Can we do something about this? 12 and 75. Well, 75 right away speaks 3 times 25. So 3 goes into these. So what happens if we pull out a 3? So common factor of 3. So if I pull out a 3 from here and a 3 from here and a 3 from here, I'm going to get 4x squared, positive 20x's, right? 60 divided by 3 is 20. And 75 divided by 3 is 25. So if you're down to this point, like I showed you in the previous lesson, many of you are going to use decomposition, right? You're like, oh, but I'm still stuck with the 4 in the front. Yeah, sure. 4 times 25, 100. Think of all the numbers multiplied to 100, probably 10 times 10. And you would do your 3 steps for decomposition. Or you're going to notice that it's a perfect trinomial. Again, oh my goodness. One of these days, I'll remember to write the nomial part. So it's a perfect trinomial because you know the square root of 4, you know the square root of 25. So it's not guess and check, there's an actual pattern here. So again, you could do it as 2 brackets or 1 bracket with a square on it right away. Break down the 4, break down the x squared into x and x, break down the 25 into 5 and 5, and the middle guy dictates the sign because I know they both have to be the same. All right, so most people, again, keep writing the 3 down in the front, are too lazy to write the 2 brackets and just put a square on 1 bracket. So that saved us from having to do decomposition because we noticed a pattern with our A and our C term. So if the A and the C term are these perfect square numbers, then we can go right into 1 bracket and put a square on it and keep the sign of whatever the middle term is, right? Keep the sign of whatever the middle term is. Always still common factor first, because sometimes you don't see the perfect square numbers are sitting there until you pull out something. And then you'll see, oh, 1 and 36. Okay. Oh, and you pull out a 3. Oh, 4 and 25. Okay, so then I don't have to use decomposition if I don't want to. But decomposition would work too. It would just have taken 1, 2, 3 lines, right? Extra. This, you go straight to the final answer. So again, I'm showing you other techniques so that you can always select the most beneficial one in each situation. All right, till next time.